Hey guys, today we're going to do notes over how to prove that a quadrilateral is a parallelogram. So we've have 5 ways in order to prove that a quadrilateral is a parallelogram. So if you can use any of these 5 ways, then you can say that it is a parallelogram. So the 5 ways are, first of all, if both pairs of opposite sides are parallel, so if this side is parallel to this side, and if this side is also parallel to this side, then you know that it's a parallelogram. That's one of the ways you can prove it. Another way is if you have both pairs of opposite sides are congruent, so this side is congruent to this side and this side is congruent to this side, then the quadrilateral will be a parallelogram. If both pairs of opposite angles are congruent, so if this is congruent to this and this angle is congruent to this angle, then you can prove that the quadrilateral is a parallelogram. And then if diagonals bisect each other, so if this is a diagonal and this is a diagonal, and those diagonals bisect each other, so this part will be congruent to this part, and this part will be congruent to this part, then the quadrilateral is a parallelogram. And if one pair of sides is both parallel and congruent, it's got to be the same pair of sides. So if this side is congruent to this side and it's also parallel, then you know that it's a parallelogram. So if you can show any of those 5 ways, then you can show that it is a parallelogram. All right, let's look at some examples. Okay, for these examples below, we're going to determine if there's enough information to show that it is a parallelogram, and they want us to justify our answer. So if nothing applies, you're just going to write not enough information. All right, so in this first picture on number 1, if you'll notice right here, you've got this angle here is congruent to this angle here. Well, those are alternate interior angles because this is a transversal that's going through these lines right here and here. So that makes those lines parallel to each other. So I'm going to mark that. This line is parallel to this line. And then you've also got, let's see, you've got these angles here congruent to these angles here. So that's going to mean that these lines are parallel to each other. So yes, that's enough information to prove that those two, that quadrilateral is a parallelogram because both pairs of opposite sides are parallel. Okay, on the next picture, yes, you can prove that that is a parallelogram. And that's because both pairs of opposite angles are congruent. Okay, on the next picture, we would say no. You don't have opposite sides congruent. You have consecutive sides congruent. So we'd say opposite sides are not congruent. Okay, on the next picture, we would say yes. And that's because diagonals bisect each other. Okay, on the next picture, we would have to say no. You've got one set of diagonals that are bisected, but the other one isn't. You've only got one set of opposite sides congruent, so this would be not enough information. Okay, on the next picture, again, we would have to say no. You should really think about this for a second. This angle here is congruent to this angle here. Those are alternate interior angles. But the fact that those are the angles that you've marked congruent means that these are the lines that are parallel. And our last rule said that you've got we had on our picture up there. If you've got one set of sides that are both parallel and congruent, then you can prove that the quadrilateral is a parallelogram. Well, we don't have the same set of sides both parallel and congruent. So we don't have this situation. So we would have to say no. That's because not enough information. It could be a parallelogram. We just don't know for sure. We don't have enough information for that. All right, let me scroll that up. Okay, on number 7, we would say, in this case, we would say yes. And the reason again is, notice that these alternate interior angles are congruent. And if those are the alternate interior angles that are marked, then these are the lines that are parallel. And that's the same set of sides that are both marked parallel and congruent. So one pair of sides are both parallel and congruent. All right, on number 8, this one's a bit tricky. So if you'll notice right here, you've got this is congruent to this. Well, that's on a triangle. If you'll notice right here, this is a triangle. So that makes this an isosceles triangle. And we know that if you have an isosceles triangle, then you know the base angles are going to be congruent. So this angle will be congruent to this angle. You also know that vertical angles are congruent to each other. So this angle will also be congruent to this angle. And then you've got another isosceles triangle over here, so its base angles are going to be congruent. So now that you have that marked in your picture, the fact that you've got this angle congruent to this angle means that those are alternate interior angles that are congruent. And so now you've got these set of lines are parallel as well. So you've got the same set of one pair of sides that are both parallel and congruent. So yes, we can say that that's a parallelogram, and it's because of the same reason as before. One pair of sides are parallel and congruent. All right, let's do some actual proofs. Okay, on this first one, we're told AE is parallel to CF. So I'm going to mark that. I'm going to mark that in my picture as well. So AE is parallel to CF. I also know that AE is congruent to CF. Now that I've got it in my proof, I'm going to mark it in my picture. So AE is congruent to CF. I also know angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. And then I've run out of room, so I'm going to mark on the next one. Segment AD is congruent to segment BC. So AD is congruent to segment BC. So these were all given to me. All right, and we're trying to prove that this is ABCD is a parallelogram. So we had 5 ways that we could do that. Those were those 5 that we listed on the very front page of the notes. So if we can use any of those 5, if we can show that in our proof, we can prove that it's a parallelogram. Okay, so let's see what we've got. We've got one set of sides that are congruent to each other. Let's see what we can see here. We've got a triangle right here, where we've got two things in that triangle that are marked congruent. If I can show a third thing that's congruent to this triangle over here, then we would be able to show those 2 triangles are congruent to each other. So my thought process over here is that I want to show that triangles are congruent. You remember we had 5 ways to do that as well. We had angle, side, angle, side, angle, side, 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 angle, angle, side, and HL. So if we can prove that triangles are congruent, then we can use CPCTC to show that, let's see, this side here is congruent to this side over here. And if we could show that, then we'd have both pairs of opposite sides are congruent. Then we can say that it's a parallelogram. So let's see what we can do here. I know, let's see. Let me see if I can mark this in my picture a little better for you. I know that this line right here is parallel to this line right here. And this is a transversal going through those 2 parallel lines. This angle 4 is going to be congruent to this angle 3, and that's because they are all alternate exterior angles. So that's what I'm going to mark in my picture. Angle 3 is congruent to angle 4, and that's because of the alternate exterior angle theorem. Remember, if you have parallel lines and a transversal going through them, then alternate exterior angles are going to be congruent to each other. All right, now I have enough to prove that triangle AEB is congruent to triangle CFD, and that's because of angle side angle. Now that we've proven that those two triangles are congruent to each other, I know their corresponding parts are congruent, so I can say segment AB is congruent to segment CD, and that's because of CP/CTC. And now we can prove that ABCD is a parallelogram. And my reasoning would be that we've now shown that this side is congruent to this side. I've got both pairs of opposite sides are congruent. That's one of the 5 ways that we listed are possibilities to prove that a quadrilateral is a parallelogram. Okay, on the next one we've got triangle CAR is isosceles with base CR. Okay, and we also know that AC is congruent to BK, and we know that angle C is congruent to angle K. All of that information was given to me. So I'm going to mark that in my picture. I know AC is congruent to BK. I know angle C is congruent to angle K. All right, the fact that triangle CAR is isosceles, that tells me that segment AC is congruent to segment AR. And that's just the definition of an isosceles triangle. Okay, and then because you know that that's an isosceles triangle, you know base angles are congruent to each other. So you know angle C is congruent to angle, we'll have to name this angle R right here with 3 letters just because we want to make it clear which angle R we're talking about. So angle ARC, and that's base angle theorem. Okay, so now again we're trying to prove that this right here is a parallelogram. Right now we've got one set of sides are congruent. Remember, we've got 5 ways to prove that a quadrilateral is a parallelogram. One of the ways is to show that you have 2 sets of opposite sides congruent. Another way is to, so let me mark that. We had this is one way. If you've got 2 sets of opposite sides are congruent, you can prove it's a parallelogram. Also, another way is if you've got a set of sides that are congruent and a set of sides are also, that same set of sides are also parallel, that's a way to prove that it's a parallelogram. Well, there's no way for me to show AB is congruent to RK. So I'm not going to be able to use this way. I'm going to have to use this. So if you'll notice right here, we've got this angle here is congruent to this angle here. And if you'll remember, if you've got a set of parallel lines and a transversal going through them, these 2 angles right here are corresponding angles. And if those angles are congruent to each other, then you know you have parallel lines. So I know that AR is parallel to BK, and that's because of the converse of the corresponding angles. If you've got corresponding angles that are congruent, then you know that the lines are parallel. Now that we know this line is parallel to this line, I know that BARK, that quadrilateral, is a parallelogram. And my reason is one pair of sides are both parallel and congruent. let's do another one. Okay, on this next one, we're told that JKLM, that's the big one, right here, this one, we're told it's a parallelogram. So all the things we know about a parallelogram apply here, and we can use those. Okay, so we're also told that PX is congruent to QX. So this little part right here is congruent to this little part right here. All right, so let's see. We're also trying to prove that this little one, this right here, we're trying to prove that that's a parallelogram. All right, so let's see what we know. It would probably be helpful if I could prove that triangle JMX, which is this triangle right here, is congruent to this triangle right here. If I could prove that, then I could get a set of opposite sides that are congruent to each other. And I could get probably that they're parallel as well. So what I'm going to be trying to get is, well, actually, I said that wrong. I'm going to try to prove that those two triangles are congruent to each other so that then I can prove that the diagonals end up bisecting each other. This is my goal this time, is to get this marked in this picture. So I'm wanting to get that this is congruent to this part right here. And those would be parts of those two triangles that are congruent, which is why I'm trying to figure that out. All right, so let's see. I know that that's a parallelogram, so I know that JM is congruent to LK. And that's because opposite sides of a parallelogram are congruent. So now I can show that. I can show that this is congruent to this. I also know vertical angles are congruent. So this angle right here is congruent to this angle right here. I need to show that in my proof. So angle JXM is congruent to angle LXK. And that's vertical angles are congruent. All right, because it's a parallelogram, I also know that JM is parallel to LK, and that's because opposite sides of a parallelogram, oops, I think I just spelled that wrong, sorry, parallelogram are parallel, and if those sides are parallel, then that tells me that this angle right here is going to be congruent to this angle right here. So angle JMK is going to be congruent to angle LKM. And that's because of alternate interior angles. Okay. Now, I've got enough to prove that those two triangles are congruent to each other. I can say triangle JMK is congruent. Actually, I'm sorry. I said that wrong. JMX is congruent to triangle LKX. And that's using angle, side. Let's see, you've got this angle here is congruent to this angle here. You've got this angle is congruent to this angle, and then you've got this side's congruent to this side. So that would be angle, side. Okay, now then we can prove that JX, I'm going to erase some of this in my picture. And let's go back over what we have. We were told PX is congruent to QX. We proved that JM is congruent to LK because it's a parallelogram. We know that those opposite sides are congruent. We also know vertical angles are congruent. We also know that JM is parallel to LK. Therefore, alternate interior angles are congruent. So this angle is congruent to this angle. And then we were able to prove that those two triangles were congruent. So now I can say that this, what we showed was that this triangle was congruent to this triangle here. Now that I know those two triangles are congruent to each other, I know their corresponding parts are congruent. So I can say that JX, why did I write that? Sorry. JX is congruent to LX. And that's because of CPCTC. And now you can say that that quadrilateral is a parallelogram. So JPLQ is a parallelogram. And it's because a quadrilateral has diagonals bisecting each other. And that's enough to prove it's a parallelogram. Okay, so your assignment has 6 that you can practice on your own. You should be able to also see the answer key for them so you can practice and kind of check your answers. Okay, thanks y'all.